am Marloes Peters, and in this video I'm going to talk about my PhD. In a previous video I've shown how we use something as simple as thermometers to measure heart attacks. And the purpose of my PhD was to look at neurotransmitter levels. So neurotransmitters are compounds in your body that give off different signals, and they have a variety of functions. This is a little bit about me. So I graduated from Eindhoven University of Technology with a degree in chemical engineering and chemistry. And after that, I decided to take up a PhD at University of Hasselt, which is in Belgium. Now here you can see that after that, I decided to move to the UK, which is about 6 years ago, where I did is what we call a postdoc. So that's a position that you do after your PhD at Queen Mary University of London. And I started my independent research career. So this is when I started my own group and when you start supervising PhD students at Manchester Metropolitan University in 2015. So last year I moved to Newcastle University, and there I am a senior lecturer in electrochemical interfaces, or you might know this better as an associate professor. And what we were interested in is looking at different neurotransmitters, and in particular serotonin and histamine. Well, these neurotransmitters are strongly associated with mood, so with your appetite, with whether you're motivated. But some of it, surprisingly, a large quantity of these neurotransmitters is also in the bowels. So it's a little bit unsure what they actually are doing there. And for my PhD, the idea was to look at if these neurotransmitters in the bowels could have an influence on functional bowel disorders. So I wanted to show this because when you are tasked with your PhD, for all of you who are just starting, you often have very big ambitions and you have a big ambitious project. So the main aim of my project was to look at these neurotransmitter levels in vivo. So while I was able to look in blood samples, for instance, we obviously never get to the in vivo part because you can imagine how difficult it is to work with patients. But nearly 10 years after starting my PhD, you could see that my PhD supervisor, Professor Wagner, published this paper that looked at function lines in catheters or looking at patient samples. And I'm glad to say I'm still involved with this work. So this is for all of you, just to understand that when you do your PhD, it never quite works out the way you think it does. So here you can see the general picture of what a sensor is. So you've got something particularly that can recognize analytes. If you look at a biosensor, this is a biological receptor. So for instance, an enzyme or an antibody. And then that's converted into a measurable signal. Usually that's the current or an electrical current. So what do we do when we look at biomimetic sensors, which was actually part of my PhD, is to change these biological receptors with synthetic alternatives. So this could be DNA. This could be molecular machines that got the Nobel Prize a few years ago, but we are particularly interested in molecularly imprinted polymers. The goal of my project was to determine whether you had binding to the polymer by using electrical resistance. And the funny thing is, when I started developing these polymeric compounds, I had another researcher in the group, Bart van Grinsen, who now works at Maastricht University, and he found out that he could monitor changes in DNA using the thermal resistance. So rather than using an electrical current, they look at the heat flow through samples. The way this works, if you have DNA, which is a double strand, it nicely stands up like this, and the heat can easily flow through. However, when you start melting your DNA, so it becomes a single strand, it collapses on your surface. So it creates another additional barrier on the surface. So it's very difficult for heat to pass through, and your thermal resistance actually increases. So he was working at the same research group as I was, working with Professor Wagner. And then we decided to see whether we could actually apply this principle to polymers as well. So while I initially was working with electrical detection, some of the drawbacks of that is that you need sophisticated equipment. And the analysis was not quite straightforward. So we decided to look if this principle could be applied to polymers as well, because remember when in DNA it was a change on the surface. The polymers that I work with, they're very porous, so they basically have holes in them. And we propose that if you get binding in these holes, you get both a blocking of the electrical current, so higher electrical resistance, but also in the thermal resistance, because we know that heat flow seeks the path of the least resistance. Because his thermal analysis was a completely new way of measuring things, we gave it a name, which was the heat transfer method, or short for HTM. And all of these devices were developed in-house. So what you can see here, if I open up the cover, You can see what it looks like in here. And briefly here, you can kind of see what these flow cells look like, which tend to be 3D printed. So they have a little hole in there in which we can put like an electrode, which is functionalized with the polymers. And then we also have a syringe pump, which is necessary in order to administer the samples to the setup. What are the main conclusions from this? What I would say, and I think what you've also seen in my example, that a PhD can be very unpredictable. So you might have the grand idea in the beginning, but then you start exploring other avenues that might work better. So in my case, why I was particularly interested in this project, because it combined working with a hospital, with an engineering department and a chemistry department. And I would say that definitely this type of multidisciplinary research I find very interesting, but it is also challenging because you have to communicate with a lot of different people. And I would say that's a great future for using these polymers in sensor applications. So what's next for this research? Well, I'm glad that I'm still collaborating with my former supervisor, Professor Patrick Wagner, and also the researcher, Dr. Gideon Wackers, who's working on this project. And the idea is to functionalize a catheter with our polymers and to look whether we can actually look at patients. So whether we can monitor directly in the bowels what the level of their neurotransmitters are. And the idea is that if we can directly monitor this in vivo after they've, for instance, had certain meals, we're hoping this would give us more insight in what these bowel disorders are and how we could potentially also help these people, because we still don't know very much of what's going on.